Hello everyone, this is Prasad. On behalf of Unacademy, I welcome all of you for another session on hybrid electric vehicle. In this session, we are going to discuss different types of drive cycles and certifications. Before this, we have understood that hybrid electric vehicle is combination of the electric powertrain and the ICE powertrain, and we have also understood further details such as what are different schematics of hybrid and electric vehicle powertrain. We have understood that in case of normal IC based powertrain, the major components are IC engine, the clutch, the gearbox, and the final drive. And in case of electric vehicle powertrain, the major components are the motor, the controller, the battery, the BMS, and various other components. The hybrid electric vehicle configuration is combination of these two, and we have learned this in very much details. We have also understood till now that how the block diagram of hybrid electric vehicle powertrain is formed. On your screen also you can find that it is combination of the two powertrains, that is conventional IC powertrain and the electric powertrain. Here we have also understood different configurations of these powertrains, and we have also had the overview of pure electric powertrain, wherein there is an onboard charger, there is a battery, there is an electric powertrain, means there is an inverter which is a bidirectional, and there is electric motor. We have also understood different types of electric motor, may it be AC induction motor, may it be DC motor, which is a DC series DC shunt motor. Also we have understood specific motors such as BLDC motor, the PMSM motor, and also the switch reluctance motor. We have also understood further how exactly power flows in case of electric vehicle powertrain. We have understood that there are different voltage levels, high voltage and low voltage. Main motor runs at a higher voltage levels and some auxiliaries are running at low voltage levels. So we require some DC to DC converters for converting this high voltage into low voltage, which is used to run the auxiliaries. We have further understood that the powertrain design is dependent on the various parameters, and hence for that we have understood the dynamics. We have understood there are three main forces that are acting on any vehicle. We have understood the aerodynamic drag force, the rolling resistance force, the gradient force, and the net power required to run the vehicle is combination of all these forces. Here, the most important thing is we have to understand that aerodynamic drag force is proportional to square of the velocity. The gradient force and the rolling resistance force are majorly dependent on the mass and type of the road on which the vehicle is moving. We have understood the detailed equations, like here you can see P, which is the total power required, okay, is nothing but Ft, that is the tractive effort, and that is equal to m dv by dt, which is nothing but ma, mass into acceleration, plus cr mg cos alpha, this is rolling resistance force, plus 1 by 2 cd rho a into v plus vw square. In most of the reference books or research papers you will find here we only consider 1 by 2 cd rho a into v square, plus this is nothing but the aerodynamic drag force, and the last is mg sin alpha, this is gradient force. So we have got all these details, and now it is time for us to understand what is drive cycle. I hope all of you know, when we are doing manufacturing of any product, maybe it is electric vehicle or any other component, that requires certification, and for that certification it requires some standard testing. Now when you are considering the vehicles, the basics are, when you design any concept, we consider worst possible situation, and we consider the design factor or factor of safety. Like when you are designing electric vehicle, for example two-wheeler you are designing, then you have to take into consideration all possible terrains, that vehicle whether it is going to run only in city, or it is going to run on highways, or it is going to run in hilly areas, it has to climb some slopes. All these considerations you have to take into mind, and you have to design the vehicle as per that. So it is the design of vehicles or the powertrains considering maximum performance targets, but most often vehicles run below that maximum or worst condition. So always in life also we should prepare for the worst. Okay, we should prepare for the worst situations. If it happens, then we are ready to face it. In same way, when you are designing a vehicle, we always take care that what is the best possible performance that vehicle can give as an output.